Yes. Yeah. Okay. Yeah. So yeah, this Wednesday. So the finals this Wednesday from 6 to 7:50 p.m. The classroom is the same. So of course you are allowed to use a formula sheet, your own formula sheet. So please prepare your own formula sheet, and you can also use the formula sheet that I gave you the beginning of the semester, and of course you can use your calculator. Um, so so I'm gonna do today. I'm gonna go over the review sheet, the final review sheet, but also I'm gonna make some comments about the second test. So I didn't finish. I think there's only one or two person. So I didn't finish actually with the grading the second test, but almost done. So I'm gonna just make some comments about the most common mistakes in the second test. Okay, and as you know, in the final, it's just combination of the second test and the first. So if you did really well in the second test, so you can probably answer more than the half of the questions in the final. um all right, so yeah, so this is a review, final review. And as I said, so I'm gonna start with the second test. I'm gonna just make some comments about the most common mistakes. So I'm gonna start with the problem number one in the second test. So this is problem one in the second test. And actually, this problem one in the second test, it's very similar to the problem. Let's see, in the review sheet. So that will be problem 7 in the review sheet, right? So this is the same. I mean, the idea is just the same formulas, right? We're gonna apply the same formulas. It's just the different numbers, right? So this is the same problem, same as the problem I said. Yeah, problem 7. Problem 7 in the review sheet. Okay. So so in the test, or I mean, I can do the one in the test, or but I wanna, as I said, make some comments about the test. So I probably prefer to go over the problem in the test. Yeah, no problem, Amy. So for the first problem, so we have this recent. So just to remind you the problem, you have a recent study that shows that 30% of New Yorkers are tested positive to the COVID-19 antibody test, right? And tested positive, let's say. Okay, and then and you have this grocery store in the Bronx, and there are like 6 customers, right? We have a group of 6. Of 6 customers in the grocery store. Anyway, so whenever you see like a percentage, 30%, that's a percentage, of course. Okay, you see a percentage and you see a number. Okay, then that's probably a binomial distribution. Okay, that's probably section 6. In section 7, it's more about the mean mu and the standard deviation sigma, right? And you have to determine the probability of x. So anyway, so what I'm saying is, whenever you see like a percentage and a number, that's probably a problem about a binomial distribution. So in a binomial distribution, you have the size of the sample, So here we have a group of 6 people or 6 customers. So n is 6. Okay. So like in the problem 7 in the review sheet, so we have a group of, suppose we have a random sample of 7 New Yorkers, right? So in the problem 7 in the review sheet, it's a sample of 7 New Yorkers. So we have a group of 7 people. Okay, so 7, that will be the size of the sample. That's your n, okay? And you see there's a 60% in the problem 7 in the review sheet. So 60%, that's probably your probability of success P, right? So here, the 30%, that will be probability of success P. So P is 30%. In other words, so remember guys, the percent means division by 100. So it's like 30%, 30 over 100, and that's 0.30, okay? Now, once you have the n and the probability of success, probability of success P, okay, you can answer any question. Because, so the first question, I think most of you got this question right, but let me just remind you how to do this first question. So the first question is, what's the probability that, exactly 2 customers, customers have COVID-19 antibodies in the blood, right? 2 customers have COVID, etc. Anyway, so you see exactly 2. So the 2 here, that will be the number of successes R. Okay, so R, the number of successes. So in this problem, R would be 2. So we want the probability that R is equal to 2, because we want R to be exactly 2, right? This is exactly. So it's just R equal to 2. Now, I'm going to just remind you how to find such a probability, right? So all you have to do, guys, is to use the table number 2. Actually, I don't know, I think one person or 2 said the probability here would be like, it's 2 customers and we have a group of 6, so there'll be 2 over 6. That's not true. Okay, so it's not just a probability rule here. It's really a binomial. It's a binomial distribution. So you need to use the table number 2, and in the table number 2, you have your n, and next to n you have your R, and n, the first value of n I think is 2. You have 3, etc. So in our problem, n is 6. So you go to n equal to 6, and then next to 6, that's the number of successes R, and R goes from, so if n is 6, R goes from 0 to 6. So you have like 0, 1, 2, 3, 4, 5, 6. Okay, so if n is, I don't know, if n is 4, then R would be 0 or 1 or 2 or 3 or 4. Okay, so it goes from 0 to n. Now next to R, you have the P, the percentage, right? So you have like a point, I think, 0.01, then you have like 0.05, and then 0.01. But in our problem, the percentage is 30%, which is, as I said, it's a 0.30. So we need to go to 0.30. Okay, so we are in this column here with the 0.30. That's the 30%. All right, and now I can find my answer. So it's this column here with the 0.3%, 0.30, and our R is 2. So here's my R. When n is 6, R is 2. So the answer, I think it's 0.324. Let me see the. Yes, so it's 0.324. So the answer here, 0.324. Now, if you want to convert this to percentage, and this is another common mistake, So you need to take 2 digits, guys, after your decimal point, and then you put your decimal. So this is 32. So take 2 digits and then put your decimal point after the 2 digits, right? So it's 32.4%. Okay, it's not 3.24. That's not true. It's 32.4%. Okay, so again, you need 2 digits, not just 1 digit. I think some of you, for some reason, when they converted the answer to a percentage, use just 1 digit. It's 2 digits, and then you put your decimal point. Okay. Yes, Juliana. So it's 0.324, but then if you want to convert to percentage, you need 2 digits. So that's a 32.4%. All right, next one. And some of you actually got this one wrong. So next, it says no more than 1. No more than 1 customer has COVID, etc. Okay, no more than 1. No more means the maximum is 1. So maximum is 1, which means it's 1 or less. 1 or less, and less than 1, that will be 0, because the number of successes are, it can be 0, right? As you can see here, R can be 0. So here we want probability that R is 0 or R is 1. Okay, so that will be probability that R is 0 or R, so plus, okay, because you have or, so that's plus probability that R is 1. So probability that R is 0, you go to R equal to 0 right here, and then you can find your percentage, which is, I think, 0.118. 0.118 plus, and then for R equal to 1, where is it? It's 0.303. Right, so then the answer is 0.421, which is actually 42.1%. Okay, again, 2 digits, and then you put your decimal point. Okay, so that's no more than 1. So maximum is 1. So if it says, for example, no more than 3, so the maximum is 3, so there'll be 0 or 1 or 2 or 3, okay, etc. Now, the other common mistake is next question, which is, so it says that we want the probability that at least 5 customers have COVID. So at least 5 customers. So 5 at least means the minimum is 5. So the minimum is 5. Okay, the minimum is 5. Okay, so that'll be 5 or more than 5. So it's 5 or more. And because we have just a group of 6 customers, so 5 or more, so that will be, as you can see here, 5 or more, so it's 5 or 6. Okay. I don't know why some of you just take like the sum of all possible R here, like R equal to 0 plus R equal to 1 plus R equal to 2, etc. That's not true, or plus R equal to 4 and then plus R equal to 5. So here, at least 5, it doesn't mean no more than 5. It's at least 5, so that's the minimum is 5. So there'll be 5 or 6. So here, so 5 or 6. So it's just R equal to 5 plus R equal to 6. Okay, so there is difference between no more and at least, right? No more, that's so the maximum, no more than 1, the maximum is 1. At least 5, that's the minimum is 5. All right, so of course, probably that R is 5. I think it's 0. Again, it's from the table number 2. You go to r equal to 5 here. I think it's 0.01. And then for r equal to 6, it's 0.001, right? I think that's all right. Yes. All right. So then the answer, it's just 0.01 plus 0.001. So then the answer is 0.011. Okay. And now, if you want to convert this to yes, Juliana, it's 0.01 plus 0.001. Now, if you want to convert this to percentage, right? So this is my 2 digits. So this is my 2 digits. So it's 1.1. So it's 1.1, and I think I need to mute some more. Sorry about that. Okay. So yeah. So it's you can just forget about this 0. So it's just 1.1%. All right, next. Oh yeah, okay, next question. Some of you got this wrong too. So the expected number of customers having COVID. So expected number of customers having COVID. So when you see the word expected number, as I said, that will be just the mean. It means the mean, mu, okay? And this is a probability distribution. I think some of you use the formula for the mean and for discrete. I think it's for discrete random variable. I mean, you can do that, but you have to find the probability distribution of this, the R, etc. But the mean for this binomial distribution is very simple. It's just n times p. Okay, so it's just n is we have a group of 6. P is the 30%. Okay, so in other words, this is 6 times. Again, percent means division by 100. So 30 by 100, that's 0.3. So 6 by times 0.3, that's 1.8. Right. But then the standard deviation. I don't know what's the problem here, but so the formula for the standard deviation sigma. So standard deviation sigma should be, it's actually a square root of n times p times q. Okay. And for some reason, some of you multiplied like 6. So n is 6, that's true. Times p, it's 30%. It's not the answer. It's not the 1.8. The 1.8, that's the mean, right? So you can just forget about the mean. So it's it's square root of n is 6 times the 30%, or 0.3. Okay, that's the 30%. This is the 30%. All right, times the q. The q is 1 minus p. The q, that's the probability of failure. That's 1 minus p. So it's 1 minus 30%. And as I said, 30% is 0.30. So that's 0.70. So here should be times 0.70 or 0.7. Okay. So if you multiply 6 by 0.3 by the 0.7, that's square root of actually 1.26. Okay. And we are not done yet. That's not the answer, because you need to take the square root of 1.26. So the answer, actually, a square root of 1.26, that will be, I think, 1.122, and that will be the answer. Okay. Any questions so far, guys? So you should expect very similar problem I mean, in the final, right? Because binomial distributions are a very important distribution. Just a similar problem, different numbers, of course. So whenever you see like a percentage with a number, a group, or a sample, then that will be just a binomial distribution. All right, and please use the table number 2. Yeah, the grade. Actually, I can send you a message. Your grade, Shakwana. Yes. Yeah, I can do that. Sure. Yeah, I can. If you email me, I can tell you exactly what your grade in the second test. Yeah. Yeah. Okay. Okay. Yeah, sure. I have to check the grades. Yeah. Yeah, I can do that. Sure, no problem. Yeah, please send me an email because I have to check the test. I mean, I don't have like the grades on top of my head. I have to check the grades in my notes. But yeah, just send me an email, or I can probably message I can send you your grade and the mistakes you made in the test. Yeah. Any question about the binomial distribution? Yes, Juliana. Oh. Q always 1. Q is always 1 minus P. It's not 1. Q is always, so Q, it's always 1 minus P. Okay. The percentage you have in the problem, like here we had 30%, right? That's your P, the 30%. So the Q is 1 minus P. Yeah, that's always true. This is always true. Q is 1 minus P. Yeah, all the time. All right. So okay, that's for problem 1. I can talk, I guess, make some comments about was the equal. What do you mean? Example? Yeah, like in this, I mean, like in this problem, we had P, 30%. And as I said, percent means division by 100. So that's 30 over 100, which is 0.30. So then Q is 1 minus this 0.30. So that's 0.70. Or in other words, this is 0.7. 1 minus P is equal to 1. Okay. Okay, perfect. All right, so now let me talk about problem number 2, guys, and the most common mistakes in problem number 2. I think most of you actually, as I said, I didn't finish grading. There's only one person left, I think. I think so, but I can tell you that the second problem was, most of you got the second problem right, which is good. So I'm gonna talk about this second problem anyway. So so this is problem 2 in the test, and in the review sheet there will be problem 8. So this is similar to the problem 8 in the review sheet. I can do the problem 8 in the review sheet or the problem 2 in the test. It's again, it's just up to you guys. However, the difference is in the problem in the test, in the problem 2 we had like 3 different questions, but in the problem 8 in the review sheet there are like 4, and the last problem is actually it's different because that's from section 7.1. Sorry, 7.5. So yeah, well, so let me discuss the problem in the test first. So you have this x random variable, which follows, of course, random variable, which follows a normal distribution as usual. And so this x represents the length x. This is the length in centimeters of a fish caught in a lake, etc. Fish. And this x, so the length of a fish caught in this lake, the mean, the population mean, is actually 40 centimeters. And the standard deviation is 4 centimeters. Okay. So it says, first, what's the probability that the length of a fish caught in the lake is less than 34 centimeters? Okay, so x is, so here it says it's less, right? Less than 34 centimeters. Okay, so like in the review sheet, the first question, it says like it takes no more than 2.2. So no more means then no more than 2.2 means less than 2.2. So here is the same thing, less than 34. So you need x to be less than 34. So this is the symbol for less. So x is less than 34. And we want to compute the probability that x is less than 34. And again, less, when x is less than 34. So this would be the area to the left of 34. Okay. So yeah, so what we do, so we convert x to z, the variable of the standard deviation, as the standard normal distribution. So just to remind you of the formula, so your z would be x minus mu over sigma. So this is how we convert x to z. So like in this problem, so we're going to convert x to z. So that's probability that. So now instead of x, I'm going to use z. I'm going to change the variable. Instead of x, it's z now. The same inequality, it's again less. So here it's less. Okay. But then there's the 34. So I need to convert this 34 to z. So I'm going to write again 34. And to convert to z, as I said, we need to subtract the mean and divide by the standard deviation. So subtract the mean. The mean is 40, right? The mu, it's 40. So 34 minus 40 over the standard deviation sigma. So the 4 here, over 4. Just be careful, guys. I mean, it makes difference here. The sign of z, I mean, 34 minus 40 is not the same as 40 minus 34, okay? It's important that you have the right sign here. So yeah, so in this case, you have z less than 34 minus 40, it's negative 6. So it's not plus 6, it's negative 6 over 4. And, 6 over 4, that's 1.5. So this is a probability that z is less than negative 1.5. Now, once you have your answer in z, this is a negative 1.5, and it's less. So we have the area to the left. This is less. So area to the left, right? Then you can use your table 3. You can use table 3, and you can get your answer from table 3, right? So the nearest, it's negative, you have your z, okay? And where's the table? So next to z, you have the nearest hundredth. You have like, 0.00, you have 0.01. So in this problem, we have, and then here we have like negative 3.4. negative 3.3, etc. Right? So here we have negative 1.5, which is the same as negative 1.50. So nearest tenth, it's negative 1.5. That's the first, take the first digit here. That will be the nearest tenth. All right, so negative 1.5. So we need negative 1.5 right here. And then nearest hundredth, that will be the second digit. So you see here 0, that's my nearest hundredth. So it's just 0, right? So you need just 0.00. For example, if let's say you have a different number, let's say you have negative 157, okay? So you're gonna need negative 1.5, and nearest hundredth would be the 7. So nearest hundredth would be 0.07, okay? Yeah. So in this case, the nearest hundredth is just 0, so that's 0.00. So the answer, like in this problem, would be negative 1.5. So it's 0.0668. Okay. I don't know why some of you got this wrong. That probably because, well, first, if you take 1 plus 1.5, that's different from negative 1.5. You don't get the same answer, okay? So be careful. If you have negative, you need to use the negative values of z, okay? Yeah, so anyway, so the answer here, probability that z is less than negative 1.5, it would be 0.0668. It's negative 1.5. So just be careful when you use the table. And one more thing, guys. So when I convert this to percentage, again, it's 2 digits. Take 2 digits after a decimal point, and then you can put your new decimal point. So that's like 06.68%, which is the same as 6.68%. You can just ignore the first 0. Right? So again, this is like in the review sheet. The problem number 8 in the review sheet, it says like it takes no more than 2.2 hours. So your x would be less than 2.2, and then you convert to z. Same thing. You subtract the mu, you divide by sigma, and then use the table. Okay. Next question. That was also a problem for some of you guys. I mean, yeah. So it says we want the probability that the length of a fish caught in the lake is between 34 and 42 centimeters. So you want the probability that x, the length of the fish, is between 34 and 42. Okay. So the idea is the same, right? So you convert x to z, you subtract usual the mean. The mean, again, it's you take this number, oops. So you take this number here, 34. So here is again my 34. And then you subtract the mean, which is in this problem, the mu, it's the 40 centimeters. So you subtract 40. Okay, and you divide by sigma. In the problem, sigma is 4, right? Right here. Here's your sigma. So you divide again by 4. The same thing for the 42. So it's like 42 minus 40 over 4. All right, so that's probability that, so 34 minus 40, that's negative 6 again, over 4. 0. Sorry, this should be z. Right, because we convert x to z, so we change the variable. And this is z, so this is 2 over 4 now, positive 2. So in other words, this is negative 1.5, then z, and then 2 over 4, that's 1/2, so that's 0.5. We cannot use our table yet. We are not done yet because I need to write this now in terms of areas to the left. Okay, so this area between, this is the area between two numbers. Area between two numbers. And the area between two numbers is always the difference between the areas to the left. So you take the area to the left of the second number, the 0.5. So probably the z is less than 0.5, minus the area to the left of the other number, which is negative 1.5. And now I can use my table, because now everything is expressed in terms of the areas to the left. This is area to the left, this is area to the left. So now I can use my table theory. Okay. So for 0.5, nearest tenth would be 0.5. Nearest hundredth, well, you can add 0 here. Okay. Because 0.50 is the same as 0.5. So nearest hundredth would be just 0.00. Okay, so nearest, as I said, nearest tenth is 0.5, nearest hundredth is just 0.00. And then I think the answer is 6915. So 0.6915 here. Okay, so here it's this is table number 2, of course, table 3, sorry. Table 3. So as I said, it's 0.69115, 15 minus, and then negative 1.5. We just I'm gonna just erase this first. So for negative 1.5, we got this is from the first question. We got 0.0668. So it's 0.0668. 0.0668. Okay. And yes, and then the answer, where's the answer? And the answer is I'm gonna just probably check for the answer. It's 62 point, so it's 0.6247, which is 62.47%, right? 2 digits after the decimal point. All right. So whenever you see like you need a probability between two numbers, so that's exactly what you have to do. Okay. And again, you're gonna have the same thing in the final. So I mean, I don't think, I mean, there's no excuse that you get this wrong in the final. Okay. I mean, you had it in the test, and now you see how it works, right? So whenever you see like what's the probability between two numbers, so that's exactly what you have to do. All right, now next question. Yeah, the length of a fish caught in the lake is more than 34, right? So we got less first, it's less than a number, then between two numbers, now it's more than. So we want the probability that x is more than 34. So x is more. So this means that x is more than 34, or x is larger than 34. Okay, and that will be the area. So larger or more than 34, that will be the area to the right. If you are more than 34 on the number line, it means that you are on the right side of 34. So this is the area to the right of 34. Okay. But as a first step, as usual, you convert to z. So this is z again, same inequality. This is the larger, so it's again larger. 34, you subtract the mean, which is we said it's 40 over 4. So that's probability that z is larger than. So again, it's just negative 6 over 4. So again, it's z larger than negative 1.5. But then we cannot use the table yet, because this is the area to the right. Okay, and the table gives us only the area to the left. And the thing is, the area to the right, it's 1 minus the area to the left. So that'll be z less than negative 1.5. So this is the area to the left. And here you can use the table. So with a negative 1.5. So that'll be 1 minus, so here's my table. 1 minus, so this negative 1.5, we said it's actually 0.0668. So it's 1 minus 0.0668, and the answer is 93. So 0.9332, 2 digits. So that's 93.32%. Okay. Any question, guys? So if you have probability that x is more, x is, so more means it's the area to the right. Less, that would be the area to the left. X less than a number, and then there is x between two numbers. One more thing, guys, because section 7.5 was not included in the test, right? So in the review sheet, so in the problem 8, there is this fourth question. It's about the section 7.5. So I'm gonna do the fourth question in problem 8. So this is problem 8 in the review sheet. So this is the review sheet. Okay, because we didn't have a similar problem in the test. This is section, so this is section 7.5. And as I said, the 7.5 was not included in the test, right? Yeah, so let's do this, the fourth question. So yeah, again, you have this variable x. So x is the time, so random variable, etc., represents the time it takes to do the laundry. Okay. And so x has a normal distribution, etc., and the mean is 2.5 hours, and sigma standard deviation is 0.2 hours. Okay, so it says like it takes no more than 2.2 hours to do the laundry. So no more than 2.2, it means that that's the probability that x is less than 2.2. It takes at least 2.95. So at least 2.95, it means the minimum is 2.95. So x has to be larger than 2.95. Next, it says it takes between 2.25, 2.75. So your x is between 2.25 and 2.75. But then the fourth question, that's the new thing here. So suppose we have 40 people selected at random. Okay, so we have the group of 40 people. So we have a group of 40 people. Okay, and then selected at random, etc. So what's the probability that the mean time x bar? So be careful, guys. So there is difference between x and x bar. So x is the variable, x bar, that's the sample mean, or the sample mean time in this case, right? So x bar, you see this x bar? So this is the sample mean. Okay, so that's different from x. It's not the same thing. Okay, that's the sample mean time. X is just the time, okay, to do the laundry. So x bar, that's the sample mean time. So it says, what's the probability that the mean time x bar to do the laundry for these people is no more than 2.35, no more than 2. X bar is no more than 2.35. Okay, so no more than 2.35 means maximum is 2.35, right? So your x bar has to be less than this 2.35. So here we want the probability that x bar is less than 2.35. Okay, so this is no more than means less than 2.35. All right. Now, as I said, so this is different from the previous questions because it's not x here. We are talking about the x bar, the sample mean. Now, to convert the sample mean x bar to z, we use a different formula. So just to remind you, to convert now x bar to z, we use the following. So formula, so it's x bar minus mu. This is just the same thing as before, but then when you divide, it's different. So here we divide by sigma over square root of n. It's not just sigma, it's sigma over square root of n. Okay, so we have our mu, the mean, 2.5. We have our sigma. So the question, of course, is what's this n? Well, n is the size of the sample. So n, that's the size of the sample. So here we have a group of size of the sample. So we have a group of 40 people, right? A group of 40 people means the sample, the size of the sample is 40, right? Because we have 40 people. That's our sample. So n here is 40. Okay. Because we have 40 people. So yeah, so if you convert this x bar to z, so instead of x bar, now we're gonna have z. This number, you take this number, which is 2.35. You subtract the mean. So the mean in this question is 2.5. So it's minus 2.5 over this sigma. Sigma is 0.2. Right, over square root of n. So it's square root of 40. Okay. So just my advice for you guys, because here it's easy to get confused. I mean, when you compute this thing here, it's better to divide first. You need to, I guess, compute this thing here, the 0.2 over square root of 40. Okay. It's better to do this first, the 0.2 over square root of 40. So like here, the 0.2 over square root of 40, that will be equal to, I mean, you can compute square root of square root of 40, right? Which is, let me see my notes, square root of 40. It's actually approximately 6.324, I think. Okay, and then you divide the 0.2, let's say, by this 6.324, let's say. Okay, so the answer would be like 0.031, etc. All right, so our x bar, which is less than 2.35, as we said, so it's z here, we said 2.35 minus 2.5 over 0.2 over the square root of 40. So that's equal to, so I'm gonna compute this thing here in the top. 2.35 minus 2.5, that would be negative 0.15. So we have negative 0.15 divided by, and then I'm gonna compute, well, we computed actually this 0.2 over square root of 40. We said it's this number right here, right? It's the 0.031. Okay. And then, yes, so then you can just divide now. As I said, again, this is just my advice. I mean, of course, you can compute this thing. It's up to you the way to compute this thing, but I think it's better to to divide the sigma by the square root of n first. Anyway, so yeah, so then this 0.15 over this 0.031, 3, 1, I think that would be like 4. So this is negative like 4.83 or something, okay? And then this is because this is the area to the left, you can use the table, right? And then here, just use the table 3, okay? Okay, let me see if there's any question. Is there any question, guys, in the so far? So yeah, so this question actually covers section 7.1, which was not included in the second test. All right, if there are no questions, then let me see the test again. So that's problem number 2. Problem number 3. I don't know, some of you got problems with this problem number 3. But I'm gonna just again make some comments about it. So right, so this is problem 3 in the test. Test 2, and this is very similar to the problem. Which problem in the review sheet? It's the third problem in the like in the problem number 5 in the review sheet. To problem 5 in the review sheet. Okay. So yeah, so we have this table, a survey of 417 students. I'm gonna just remind you here the table, not the values. I'm just gonna put like the freshmen. So we have here freshmen. Here we have sophomore. I'm gonna just denote sophomore by S. We have junior. That's my J. You have senior, that's my capital S, and then it is the total, right? Now, next you have not satisfied, so NS stands for not satisfied. Then you have neutral, and then you have satisfied, that's my capital S, and then you have the total. All right. Now, I think some of you had trouble with the last questions. So for example, you want to find the probability that a student selected at random is, probability that a student selected at random is freshman. The student is freshman, given that that he or she is satisfied. Okay, so this is probability that student is freshman, given that he is satisfied, or he or she is satisfied, right? So first, guys, when we say given that he or she is satisfied, so we know for a fact that the student is satisfied, right? Because it's given, right? So it's not just like a random student here, it's a satisfied student. Okay, so the sample here, it's not all the students. The sample here is just satisfied students. So the question here is how many satisfied students in total? So the number of satisfied students in total. So this is my satisfied students, right? So in total, I have the number here is 180. Okay, so in total, we have 180 satisfied students. So here we need to divide by 180 because that's the size of the sample. We have 180 satisfied students. Okay. Now, what's the probability that the student is freshman, given that he's satisfied? So because we know that the student is satisfied, we can just forget about all the other students. So we can just forget about the other rows here. Okay. Now the question is, among the satisfied students, how many are freshmen? Okay, so the number of freshmen among the satisfied students is this one here. Okay, and that will be 23. Okay, so in the top here, we're gonna have 23. It's 23 over 180. Does this make sense to you guys? Okay. All right, now the next question, and I think some of you thought like it would be it's just the same question, but it's not. So the probability that the student is satisfied. So we don't know if the student is satisfied or not, right? So it's a probability that the student is satisfied, given that he's a freshman, so he or she. So we know for a fact that he or she is a freshman, right? Satisfied, given that the student is freshman. Okay. So this is probability that student is satisfied, given that he or she is a freshman. So what's the size of the sample here? And now, because we know that the student is, it's given, right, that the student is freshman. So we know that the student is freshman. So the sample here would be freshman students. It's not all the students, it's just freshmen, because we know for a fact that the student selected at random is actually a freshman. So the total number of freshman students, well, that will be this number right here. Okay, that's the total number of freshman students, which is actually 101. It's not 110, it's 101. Okay, so we need to divide by 101. Okay, that's the number of freshman students. And in the top, so we want the probability that student is satisfied, given that he or she is freshman, right? So among the freshmen, how many students are satisfied? Well, so you see this column, this one here, this is the column of the freshmen, right? So among the freshmen, how many are satisfied? Well, again, it's 23. Okay. So out of the 101 freshmen, we have 23 students, freshmen satisfied. So in the top, it's 23. So this is 23. Okay. And as you can see, guys, it's not the same answer. I mean, this is 23 over 180. This is 23 over 101. So it's not the same answer. It's not the same thing. It's different. Okay. So as I said, this is very similar to the problem. This is problem 5 in the review sheet. I mean, you can practice again if you want in the problem 5. And again, guys, I mean, you can ask me, you can email me anytime. I'm gonna try to do my best to answer very quickly your emails. If you have any question about the review sheet, okay, so just email me anytime, okay. Is there any question, guys? I mean, about this, you know, this problem 3 or problem 5 in the review sheet? I guess, let me see the chat. Okay, no questions. Okay, cool. All right, so let me talk about the next problem on the second test. And I think some of you got some problems with this number 4 for some reason. So you need to be careful, actually. So this is problem 4, test number 2, which is very similar to the problem 6 in the review sheet. So this is similar to the problem problem 6 in the review sheet. Okay. So in the test, yeah, actually there's some there's a small difference actually between the two problems. So in the test, we have this survey of 100 couples. You have like a number of kids, and here we have like the number of couples, and then the number of kids, it's from 0 to I think 4. And here number of couples, it's 50, it's 30, it's 10, then there's 8, and there is 2. So yeah, you need to read carefully the questions. Let me just say, compared to the, I'm gonna just compare this to the problem 6 in the review sheet. So in problem 6, this is in the review sheet. So you have your x, and there is the probability of x, right? And then you have like 1. So x goes from 1 to 6, I think. 4, 5, 6. And then this is 0 0.1, 0.2, 0.3, 0.05, 0.15, and 0.2. Okay. So the difference between the two tables, the second table, this is a probability distribution, because for each value of x, you assign the probability of x. When x is 1, the probability that x is equal to 1 is exactly this number here. It's the 0.1. Okay. When x is 2, the probability that x is equal to 2 is 0.2, etc. So for each value of x, you're gonna assign the probability of x. And that's what I call a probability distribution. This is what I call the probability distribution. Okay. And of course, a probability, it's, you see the numbers here in this probability distribution, the probability is always a number between 0 and 1. Probability cannot be a number larger than 1, larger than 100%. Okay. Now the difference. So you see the difference with the table and the test. In the test, here we don't have probabilities. So here, the second row, that's not probability that x equal to 0. So the 50 here, this is the number of couples with 0 kids. It's not the probability that the couple has 0 kids. This 50 here, that's the number of couples with 0 kids. Okay, so so first, for this problem here, we need to find the probability distribution of this table, the couples with a number of kids. Now, so what's the probability distribution of the first table? So this is so let's say this is table 1. This is my table 1. Okay, and here's my table 2. Okay, now we just forget about the table number 2, because table number 2, that's probability distribution. Now I need to find the probability distribution of the table number 1, of table 1. Okay, this table right here, this one. Okay, the kids with a number of couples. So again, so it says, so let the variable x be the number of kids. So x, this is the number of kids. And we, the p of x, this is the probability that a couple selected at random has x kids. This is a probability that a couple selected at random has X kids. For example, if X is 1, what's the probability that a couple has 1 kid, for example? Okay, has X kids. So we need to find this probability for each X. So that will be our probability distribution, right? So, so for example, what's the probability that X is equal to 0? Okay, so the probability that X is 0, this is probability that a couple has, so this is the probability that a couple has 0 kids. That a couple has 0 kids or 0 kid. Okay, well, so how many couples in total we have? We have 100 couples, right? That's the size of the sample. We have 100 couples in total, right? And how many couples with 0 kids? It's 50, right? So when you select a couple at random, you have 50 over 50, that's the number of couples with 0 kids. So 50 over 100 chance that the couple has 0 kids. So the probability that X equal to 0 is just 50 over 100. So the 50, that's the number of couples with 0 kids. This is the number of couples with 0 kids. That's the 50. And this is the size of the sample, the 100. We have 100 couples in total, right? This is just the size of the sample. So the probability that X is equal to 0 is just 50 over 100. Which is, of course, 1/2. So probability that X is 0, that will be 1/2, or 0.5, or 50%. Okay. Now, what about the probability that X is 1? What's the probability that a couple selected at random has 1 kid? Well, you count how many couples with 1 kid. We have, as you can see, we have 30. So we have 30 couples with 1 kid. So the probability that the couple has 1 kid is 30 over the size of the sample, which is 100, right? So it's just 30 over 100. So this is 30 over 100. The 30, that's the number of couples with 1 kid. 1 kid, and this is, of course, 100, that's the size of the sample. We have 100 couples in total size of the sample, etc., guys. So I mean, I hope you see how it works, right? So the probability that X is equal to 1, that will be 0.3 or 30%, etc. So your probability distribution in this case, so again, we started with this table with a number of this table right here, this one, this table. It's not the probability distribution, it's just the number of couples with X kids, right? Now the probability distribution of this table would be, so here's your X. X is just the number of kids. Number of kids, again, it's, we have 0, we have 1, we have 2, we have 3, we have 4. Now the probability that the probability of X, probability that a couple selected at random has 0 kid, we said it's 50%, so, or 0.5. The probability that a couple has 1 kid, it's 30 couples over 100, that's 0.3. The probability that a couple has 2 kids, we have in total 10 couples with 2 kids, so that's 10 over 100, that's 0.1. 3 kids, we have 8 couples with 3 kids, so that's 8 over 100, right? So that's 0.08. And then finally, we have 2 couples with the 4 kids. So 2 couples out of 100, that's 0.02. Okay, and that's what I call the probability distribution. Any question, guys? I hope you see the difference between the 2 tables, right? First table, it's not a probability distribution, it's just the number of couples with X kids. table number 2, that's what I call a probability distribution. All right, once you got your probability distribution, then we need to find the expected number of kids for a randomly chosen couple. So expected number of kids. So expected number, as I said, that's always like the mean. It means the mean mu. Okay. And here in this problem, as you can see, there's x and there's p of x. Okay. And the mean, if you have your x for a discrete variable, if you have your x and p of x, the mean is just the sum of x times p of x. So once you have your x and your p of x, then you can compute the mean. So like in this case, there will be first x is 0. So that's 0 times 0 0.5, etc. So it's 0 times 0 0.5 plus 1 times 0 0.3, 2 times 0 0.1, 3 times 0 0.08, and then 4 times 0 0.02. All right, so that's 0, 0 0.3 plus 0 0.2 plus 0 0.24 plus 0 0.08, and the answer, I guess, so 32. So the answer, so this is 5, 0 0.5, 0 0.7, 74, and so that's 0 0.82. That's the expected number of kids. So what we are saying is, if you select a couple at random, you expect that the couple has like 0.82 kid, which is like close to one kid. Okay. Any question, guys? Please, if you have any, don't be shy. All right, so as I said, this is very similar to the problem 6 in the review sheet. You have your probability distribution. You can just compute the mean, etc. What else? Okay, and then last problem in the test. So this is problem number 4. Yeah, problem 5 in the test. So I'm going to remind you of the problem. I think, well, I think half of the, I mean, some of you got this one wrong. So I guess that's probably a good idea to do it again. So we have our x. X is normally distributed. Okay. The mean, you know that the mean is 25. The standard deviation is 2. And the question is to find the value of x. Find x says that 20% of the normal distribution, or the area of the graph of the normal distribution, lies to the right of x. So 20% of the area of the normal distribution of x, normal distribution of x, lies to the right of x. The right of x. Okay. So in this problem, there is a mu given, there's sigma, it's given, right? But here, I mean, usually when we have like a sigma and mu, then I mean, usually the questions are like, what will be the probability that x is less than a number, or x is more than a number, or x is between two numbers, right? But this is very different, right? It says you need to find x, right? You don't need to find the probability here. You need to find x. It says that 20%. So this 20%, that's actually the probability. So here the probability is given, right? And you need to find the corresponding x. So it's like, what we are saying is like, here's your x. This is the graph of the normal distribution of x. All right. And we know that 20% of the area of this normal distribution lies to the right of x. So for which value of x, 20% of the area would be on the right, to the right of x, right? So in this kind of question, to find x, we don't want to find the probability, right? Again, the 20%, that's our probability. So the key word here is that this 20%, it's actually lies to the right of x. It's not to the left, it's to the right. So because it's to the right, and the table, we can use the table to find the areas to the left, right? So we need to go from the area to the right to the area to the left. So for step one, we need to compute the area to the left of x. So area to the left, that will be the area 1 minus the area to the right. Okay, so the area to the left of x, of z, so that's 1 minus area to the right, that's 20%. That's the area to the right. 1 minus 20%, so that's 80%. In other words, area to the left is 0.8, or 80, 0.8. Okay. Now, once you find your area to the left, this is first step. The second step is you need to find the corresponding z. So again, this 0.8, it's not z. This is the area to the left. So you need to find the corresponding z. Step two, find the corresponding z. So you need to find this 0.8 inside the table 3, right? Find z in the table 3. Like, again, the table 3, the numbers are increasing, and you need to find 0.80. So you have like, or 0.80, or 0.8, 0.8, or 0.80. So if you check in table 3, numbers are increasing, and then at some point you have like 0.7995, and then 0.8023, right? And the corresponding z, so this is when your z is like here, it will be 0. This is 0.8, and here it's like 0.04, and this is 0.0. Yes, 0.05. Okay. So as you can see, 0.8 or 80% is between these two numbers, right? So your 0.80 or 8%, 80%, sorry, is between these two numbers. Of course, which one is going to be closer to this 0.80? Well, this is 799. And so, the difference between this and 0.800, it's just 1 here, right? And this is difference with 0.800 is like 2, right? Here, right? So the closest number to the 80%, the 0.80, is this number right here. And it corresponds to, as you can see, it's actually corresponds to z equal to 0.84. Okay. So the corresponding z, oops. So the corresponding z is 0. So z is 0.84. Okay. Now, once you got your z, now you can get your x. So now we can find x. X is actually given by, this is the formula for x. So x is z times sigma plus mu. Okay, so x is 0.84 times sigma. So sigma in this problem is, as you can see, it's 2, and mu is 25. So times 2, the sigma, times 2 plus 25. The mu, this is 25, sorry. This is 25. All right, so then x is 1.68 plus 25. So the answer is 26 point, I guess, 0.68. Okay, so that's the final answer, 26.68. So this is actually the inverse normal distribution. I mean, we did similar problems in the in the lecture, and yeah, so that's how we answer this question. Any questions? Any question, guys? So far, so good. All right, so I think I went over the whole test, which is really good. And as I said, you have similar problems in the review sheet. So, I mean, if you want to practice a little bit, you can try to do the problems in the review sheet. Now, so this is from like the second test, right? That these problems, they covered the problems in the second test. Now, because the final, it's not just about the second test. The final, it's a combination of the first test and the second test, okay? So the final covers everything. So we have in the review sheet, we have problems from chapter 2, chapter 3, chapter 4. So chapters 2, 3, and 4, they were in the first test, right? So let me just see. Well, I guess. So first problem in the review sheet. So it's about frequency table. I don't know if you have, if you guys have trouble with the frequency table. I mean, of course, I can do the first problem. Then the second problem, it's about the mean, median, mode, and weighted average, which is kind of important. So I guess I can do that now. And then the problem 3, it's about the standard deviation, etc. And then problem 4, this the scatter diagram. So I can probably, so how much time we have? Yeah, I can probably go over problem number 2 in the review sheet, the weighted average, mean, etc. Just to remind you the formulas. I can discuss the problem number 4. And then probably I'm gonna just stop. Okay. So yeah, they'll cover, I guess, almost everything. So yeah, so we have this problem 2 in the review sheet. Okay, so we have I think 8 numbers, right? You have 5, 4, 7, 5, 2, 5, 8, 5, right? So we need to find the mean first. I guess you know how to find the mean, right? Oops, sorry about that. Oops, I think I wrote a lot here. Anyway, yes, here's, sorry about that. Yeah, so the mean, guys, it just, just the sum of all the data values, plus 2, plus 5, plus 8, plus 5 over, and we have 8 numbers, so we're gonna divide by 8, right? The median, median first. I'm gonna do the median first. So the median, guys, you need to order the data values from the smallest to the largest. The smallest number here is 2. Next, we have 4. Next, we have 4 5s. 1, 2, 3, 4. So 1, 2, 3, 4, and then 7, and then 8. Okay, so the median, of course, would be the number in the middle. And I mean, here it's just 8 numbers. I mean, you can see that the middle would be just, between the 5 and the 5 here. That would be the middle point. So sorry about that. Yeah, the middle. So then the median just it's going to be the average of so this number here, because the middle is between this 5 and this 5. So the median is just the average of the 2 5s. So it'll be 5 plus 5 over 2. The mode, of course, that will be just the number. We have the most frequently here. As you can see, it's 5, right? Because 5 is repeated like 4 times, right? So the mode is just the 5. Okay. The weighted average. This is interesting. So the weighted average now. So the weighted average. Yeah, I'm gonna first remind you the formula for the weighted average. So it's supposed to be like sum of the x times the weight. So the w, that's the weight of the variable. This is x, this is your variable, and over the sum of the weights. Okay, so like in this problem, so we have Lewis. He got 70. The project, the research project is worth 15%. So the 15%, that's like the weight of the research project, right? So so the weighted average, like in this case, would be 70 points on the project, right? So 70 points. The weight of the project is 15%. It's worth 15%. So 70 times for 15%, right? Sorry. Plus, next, we have the first exam. He got 80 points on exam 1. So that's 80 times the exam 1 is worth 20%. Plus exam 2, he got 90 points. So again, this is problem 2 in the review sheet, guys. Okay, the B. Right, I'm talking about problem 2 in the review sheet. So this is the B. Yeah, so the exam number 2, where's the exam number 2? He got 90 points. So here is his score in the exam number 2 is 90. So that's 90 times. So exam number 2 is worth 20%. Exam 3 is worth 20%. He got 60 points in exam 3. So that's 60 times 20%. And finally, the final. So the final, he got, where's the final? 82 in the final. And the final is worth 25%. Divided by, so this whole thing, it has to be divided by the sum of the weights. So the first weight is 15%, plus second weight is 20%. Third weight, that's the weight of the exam number 2, it's 20%. The weight of exam 3 is 20%, and the weight of the final is 25%. Okay. Just to remind you guys, I mean, when you have percent, like 15%, that's 15 over 100. So that's like, this is like 70 times 15 over 100, right? That's 0.15. 15 over 100. plus 80 times 20%. 20 over 100, that's 0.20, etc. 90 times 20%. 20%, it's 0.20, etc. Okay, plus over in the denominator, we have 15%, so that's 0.15. 20%, that's 0.20, another 20%, another 20%, 0.20, and then 0.25. Okay, so of course here you need to multiply. You see these numbers here, you need to multiply, etc. Then you need to get compute the sum. Okay, and then you need to add the numbers here in the denominator. Actually, the denominator would be equal to 1. Okay, so here this is actually actually equal to 1. The 0.15 plus 0.20, etc., that would be 1. Denominator is 1. Okay, so all you have to do actually is just to compute the top. Oh, I got a question in the chat. We have the answer sheet. No, I don't post the answer sheet, Shakwana. That would be no. No, I don't post the answer sheet. But I mean, if you did all the problems, you can just you can take pictures of your answers, and I can tell you if your answers are correct or not. But I don't post the answer sheet. Yeah, I'm sorry because that would be
okay. That's fine. Thank you.
yeah. No problem.
I am going to send them to you.
Okay, sure, anytime.
Okay, thank you.
Thanks. All right, so that answers the weighted average. All right, guys. I mean, I think I covered almost everything. Is there any specific question, any specific request? Nope. Okay, then. Yeah, then if there's no specific request and there's no questions, then I'm gonna just probably stop here. And again, if you have any question before the exam, you can email me anytime, and
Okay,
I'll do my best to answer your question quickly. Okay. Yeah. Yeah, I'm gonna just probably stop recording at this point.